Okay, now we will discuss something about vector, dot product, cross product, direction, cosines, direction, ratios, etc. So it is very important in physics to know what is vector cross product, vector dot product, direction, cosine, direction, ratios, etc. Okay, so we have two vectors like a vector and another is b vector. And the angle length between them is theta. Between them, the equiangle, okay, is theta. This is not this angle, okay? This is small angle, theta, angle included. So, if there is two vectors are there with equiangle theta, then the result will be the product of the two vectors, dot product of the two vectors represented by a vector dot b vector. There is a dot between a and b. That's why we call it dot product. Okay. So a dot b is equal to magnitude of a, magnitude of b, cos or cosine of angle theta between the two vectors. This is the what? This is called the dot product of two vectors a and b. Okay. This is a scalar quantity, and another name for dot product is scalar product. Dot product or scalar product. Scalar product. Scalar product. Okay. And now another form. Okay. Another product, that is vector product of two vectors. Vector product or vector product or cross product. Vector cross product, cross product of two vectors. Cross product of two vectors. Okay. This cross product gives another vector. Okay. So if there are two vectors like a vector and b vector, like this, with angle theta between them, then the vector cross product will be represented by a vector cross. There is a cross sign here. B vector is equal to a b sine of the angle theta between them, and there is a direction. The direction of the cross product of two vectors will be given by right hand screw rule. Right hand screw rule. Screw rule. Not to confuse. Okay, I just want to remind the difference between the right hand screw and the left hand screw. Right hand screw. Right hand screw. Right hand screw and left hand screw. Left hand screw. Okay. Right hand screw advances towards the advances when we advances forward when we turn the screw towards the right. Okay. When we turn the screw towards the right, the right hand screw advances forward. Okay, this is the working principle of right hand screw. And left hand screw, when I turn the screw towards the left, the screw advances forward. This is the how left hand screw works. Okay. So the cross product of a vector and b vector will be given by the right hand screw. Okay. Okay. Right hand screw. Okay. So when I turn the right hand screw from A to B, or when I from A to B, from A to B, okay, the direction in which the screw advances will give the direction of the cross product. This is the right hand screw rule. Okay. In dot product, A dot B is equal to B dot A. B dot A. Okay. There's no difference. But in cross product, A dot B and B dot A are different. A cross B and B cross A are different. A cross B is equal to minus of B cross A. B cross A. B cross A. Because when I swap from B to A, the screw will turn back like this. Okay. And then the vector cross product can be represented. Vector cross product can be represented using the determinant. Okay. A vector has components along x cap, A1, along y, A2, y cap, along z, A3, z cap. And same thing, B vector has components along x cap, B2 along y cap, and B3 along z cap. So A cross B will be given by the determinant x cap, the first row, y cap, z cap, and then in the second row, the components of the first vector, A vector, and then in the third row, the components of the, like this. And this is equal to x cap, A2, A3, B2, B3, okay, minus y cap, A1, A3, B1, B3, plus z cap, A1, A2, B1, B2, right? Okay. So this is the representation of cross vector, okay, in determinant form, using determinant, okay. Representation of cross product using determinant. Okay, now let's come to direction cosines. Direction cosines. Direction cosines. Direction cosines. Direction cosines. Direction cosines are nothing but these are the cosines of the angle made by the vector with the different axes. Okay, so here there is a vector like this. Okay, along it has, okay. So angle maps are represented by like this. Okay. So this is the R vector. Okay. So R vector. Okay. R vector in component form. Let's say is A vector along the x-axis. It has along the x-axis. Its component is A1. Along the y-axis, its component is A2, and along the z-axis, its component is A3, z cap. Okay, like this. So we have now direction of the unit vector that represents the direction of a vector is given by the dividing a vector by its magnitude a, and this is equal to a vector a1x cap plus a2y cap plus a3z cap divided by a. Magnitude of a is root over a1 square plus a2 square plus a3 square, like this. Now the cosine of the angle, made by a vector with x-axis is given by unit vector along a dot x cap. This is unit vector a divided by a has unit magnitude, x cap has unit magnitude. Therefore, its product results in the form of like this. Results expression, and that is equal to cos alpha. Okay, cos alpha. But a vector dot this product results. Okay, this product results in, we have here a1 divided by root over a1 square plus a2 square plus a3 square. Okay. Because because dot product of x with x is 1, x and y is 0, x and z is 0. Therefore, the dot product of this vector and this vector is a1 divided by a1 square, a2 square, a1 square plus a2 square plus a3 square. And this is called cos alpha. Cos alpha. Like this, cos beta is equal to the dot product of a vector divided by a dot y cap. And this is equal to y cap dot x is 0 because y and z has 90 degree angle between them. So is equal to say a2 divided by root over a1 square plus a2 square plus a3 square. Okay, cos beta form. Like this, cos gamma, cosine of the angle made by the vector a with the z axis is equal to a vector, this unit vector dot z cap. This is equal to if I multiply here by dot z cap here, so this magnitude is 1, this vector also has magnitude 1, and z dot x is 0, z dot y is 0 because the angles between y and z and x are 0. Therefore, z dot z we are left with z dot a3 z cap. Therefore, the result is a3 divided by root over a1 square plus a2 square plus a3 square. Okay. Now let us see. The expression. Okay. This is the result of the addition of cos square alpha plus cos square beta plus cos square gamma. Okay. This is equal to a1 divided by over a1 square plus a2 square plus a3 square. Okay, this is cos alpha expression whole square plus cos beta is a2 divided by over b1 square a1 square plus a2 square plus a3 square and plus a3 whole square. Okay, a3 divided over a1 square plus a2 square plus a3 square. Okay, this whole square. Okay, now if I take a square, we have a1 square divided by a1 square plus a2 square plus a3 square plus a2 square divided by a1 square plus a2 square plus a3 square plus a3 square divided by a1 square plus a2 square plus a3 square. Okay, this is equal to a1 square plus a2 square plus a3 square divided by a1 square plus a2 square plus a3 square. This is equal to what? That is adding cos square alpha, cos square beta, and cos square gamma yields 1. Okay, and now, okay, what is this? A vector divided by A. This is the dividing the vector by its magnitude yields unit vector that points in the original vector. Okay, in the direction of the original vector. Dividing the vector by its magnitude yields unit vector that points in the direction of that vector. Okay. With that idea, we proceeded. Okay. Now let's see what are direction ratios. Okay. Direction ratios are nothing but these are the components of the vector along the x-axis, y-axis, and z-axis. That is, the direction ratios of the vector A vector are A1, A2, and A3. These are the direction ratios of the vector A vector. Okay. Direction ratios of the vector A vector. Now, let's see how to obtain direction ratios. Okay, from direction cosine. Okay, that means cos alpha is equal to a1 divided by this magnitude. Now, how to obtain a1? Direction ratios of a vector are a1, a2, and a3. If I multiply cos alpha by the magnitude a, okay, a is equal to how much? A is equal to root over a1 square plus a2 square plus a3 square. Okay. Therefore, if I multiply the cos alpha by this magnitude a1 square, a2 square, a3 square, we are left with this result a1. That is the component of the vector along the x-axis. Therefore, multiply the cosine of the angle alpha made by the vector with the x-axis with the magnitude of the vector yields the component of the vector along x-axis. That is the direction ratio along x-axis. Okay. And the second direction ratio, that is the component of the vector along y-axis, that is a2, is obtained by multiplying cos beta with the magnitude of the vector, that is a, okay, given by root over a1 square plus a2 square plus a3 square. That is multiplying cos beta with a, that is equal to this root over a1 square, a2 square, a2 square. Okay. Yields what? Yields the direction ratio a2. Okay. And for a3, we have to multiply cos gamma with the same magnitude of the vector, or that is a, or given by root over a1 square plus a2 square plus a3 square. Okay. We know direction cosines. Direction cosines are the angles, the cosines of the angles made by the vector with the x-axis, okay, y-axis and z-axis. Okay. And direction ratios are the components of the vector along different axes. This is regarding to direction cosines and direction ratios. Okay.